So we've had just an unbelievable day of speakers, and Rae Zimmerman was very kind to promise to be a very close listener and to help us kind of summarize and to kind of synthesize maybe some of the major themes that we saw today. And so I'm going to turn this over to Rae, and then she'll do our final remarks.
Okay, thank you. All righty. Okay, so I was told to give some closing remarks, but hopefully keep the discussion open in all of this. This workshop was so incredibly rich. It's very hard to summarize in just a few minutes what was presented. Obviously, a tremendous richness and capacity of data targeted to the subsurface does exist, and there are a lot of insights that all of the speakers shared here. But what's interesting is that there's a lot going on above ground apparent from the subsurface. So we learn what's happening around us above by evaluating the subsurface as well. And there were a number of extraordinary insights, and here were just a couple, and there were dozens upon dozens. There are, reconstructing history, the historical landscapes from the subsurface, and beginning to understand structural supports, earth retention systems for design standards, developing new design standards, changing existing ones to take into account what is happening below us. And then there are new problems, though, that some of the speakers did touch on, for example, and to think about for new data layers. Again, moving ahead, sea level rise, which is something I've worked on quite a bit as a member of the New York panel on climate change and a lot of the research I've been doing. What does that mean for the subsurface with water suddenly inundating areas that hadn't been inundated before? Risk mitigation in disasters and accidents. And secondly, in the area of new problems, uniquely understanding how things interact under there. And the challenge of grappling with especially infrastructure interactions, which my research group studies a lot, that produces cascading impacts. They not only occur above ground, they occur below ground, and below and above act together, which I'll just touch on very briefly. And there are new ways. The terrific thing about the workshop is there are so many new ways of generating and working with data, new measurement technologies, only one of many that was mentioned, ground penetrating radar. That's an older technology, but used in new ways to understand the underground system. So it's very extensive what goes on below here. This is just from Corey Kilgannon's article of a few months ago, Under the City Streets. 6,500 miles of water mains, a little more sewer lines. Con Ed has 90,000 miles of underground cables. That may extend beyond the city a bit. 1,600 miles of natural gas, and the subway 665 track miles, and as MTA likes to point out, late end-to-end New York City Transit train tracks, which stretch from New York City to Chicago. And then, of course, above this are the thousands of miles of streets. Now, there are some cautions that I just alluded to. The interaction effects below ground. Infrastructure is, as I just mentioned, heavily interdependent below ground. but a lot of the attention has been above ground, and the data that was presented, the methods presented here, really are key to understanding this. And I would love to see that applied to these problems. There are conflicts between above and below ground actions. The famous one being street salting above compromises the electric power distribution systems below. There are thousands, they estimate 2,000 to 3,000 subsurface fires per year. And not to mention the fact that manhole covers go up every so often. And there's a tremendous heterogeneity of the underground environment, which really is going to be challenging for measurement and construction. You can't just dig a hole down and expect it to give you one measurement. It's made up of a lot of different things. As I mentioned before, sea level rise with more underground flooding, it's going to be a whole new ball game here. Properties of materials, one thing I've been paying quite a bit of attention to with respect to just to heat, they may change due to environmental conditions, and underground data will have to adapt to that. And the underground, I think as Deborah opened up with, the underground is fixed and hard to move, unlike the above ground. I think Deborah pointed out you can build new buildings, but, pretty hard to work down there. And interdependency is absolutely key. I did a big research project for the Transportation Research Board on analyzing NTSB pipeline failures. And, the decomposition of decisions and perceptions is extraordinary. Either the pipeline locations aren't marked, they're marked but not communicated but there's no training or understanding or familiarity with how to deal with them. And then some future opportunities, last but not least, it's a very valuable resource, especially for urban areas where the land above is so constrained. And the underground can support sustainability upon which we depend. Just a few examples. I don't know if any of you remember the Low Line. It was open from 2015 to 2017. They were hoping to have sustainable energy sources for vegetation underground. It was an analogy to the use of the above ground abandoned rail lines. And then for environmental management, I don't know if any of you know of Kuala Lumpur, where they have something like a 6-mile stretch, a tunnel that is used to manage traffic when there's no rain, and then it's a conveyance for stormwater when during flash floods and run. You hope the two don't combine, but anyway, it's apparently they manage it pretty interestingly. And then there are ways of constructing infrastructure below grade that avoid surface disruptions like trenchless technology and that sort of a new thing. But at any rate, I just leave you with those few comments. It was hard to capture everything that went on today, which is really terrific. Thanks.